Hi there, welcome back to my beautiful channel. My name is Danny Henderson, and my guest today is the one and only Dr. Brooks Agnew. He is a multi-patented master engineer, and we're going to get into some of his work and some of his expeditions and a lot of who this man is. Dr. Brooks Agnew, welcome, sir. How are you?
It's so good to be here. We've met years ago and really haven't had a formal sit down and chat, and this is amazing. I really appreciate the invitation.
Well, I'm so happy to finally get through because we were blocked many times, emailing each other and messaging. But we did meet years ago, like 3 or 4 years ago, and we were at a conference and we met. Laura Eisenhower. I think Laura Eisenhower was with us, definitely. And we sat outside my hotel room and we had a couple of beers, and it was really nice, and it was a good fun time. And during that conference, I saw you present the North Pole Inner Earth expedition. And like I was telling you earlier, it stayed with me. It stayed right here, and I'm like, I'm not going to take my eye off that man. I'm going to make sure I track him because that expedition, which we'll get into at your leisure, is fascinating. And so I really want people to pay attention to you, to listen to your information, look at the huge body of work that you have put into the field. It's massive. You and I have good friends in common. Brad Olson, the intrepid explorer, Alex Collier, the Andromedan contactee, Dr. Michael Sala, beautiful researcher, historian, and I'm sure many others the more we sit and discuss and figure things out together. But let me turn things over to you. Where would you like to start with sharing with the audience here who you are and what you want them to know about you?
Well, I mean, gosh, we could do an hour on engineering and things that I've been involved with over the years, but this particular project fascinated me because after my late co-author, and I finished a four-part series called The Ark of Millions of Years, like Noah's Ark. It was a nonfiction series, about 2,000 pages, and it was research into 44 ancient cultures and their viewpoint about Earth, about where it came from, why it was here, what's man's relationship with the Earth. And I found it to be so deeply involved that by the time we finished this 2,000 page series, the proof was irrefutable that these ancient peoples believed that there was a symbiotic relationship between man and the planet itself. Some believed there was a life force that came out of the middle of the earth. Some believed that man actually came out of the inner earth, that the floods came out of the inner earth, and that when man was good, Earth would bless mankind. And when man was evil, Earth had a kind of allergic reaction and would rise up and kind of spank mankind back down to a few tribes. So I found this story so fascinating. And yet all of them believed that there was some structure, some origin inside the planet, not just on the surface where we live. And so after doing all of that research, and we traveled to most of these countries and took our own photographs and did our own research, it took years to write these books, that there would be some evidence out there of an expedition where someone had, say, gone to the Antarctic or gone to the Arctic and actually done an exploration to see if there was an opening from the surface of the Earth into the interior of the Earth. And to be honest, all I found were stories. All I found was hearsay. And I'm a scientist. You know that. I am a data person. I need evidence. So I learned of an expedition that was being put together out of Washington State to actually go there by sea and explore to see if there was an opening. So I joined that expedition. Well, that was in August. By October, the leader of that expedition suddenly passed away with brain cancer. So I thought, okay, well, that's the end of the expedition. Somewhere toward the end of the year, like December-ish, the board of that group contacted me and asked me if I would like to lead the expedition because I'd done a lot of big projects, a lot of big budget projects in engineering, and would I be interested in doing it? Well, I didn't just say yes. I said, hell yes. So I thought, well, okay, it's 2007. Let's see if we can put it together for 2008. Well, long story short, we did a pilot video that was 30 minutes long. We won the Genes of Galileo contest in Tokyo.
Wow.
Uh, Almost 5 million people saw our video. We
Amazing.
won a trophy, we won cash, and we thought, oh, right, we're really on a roll now. Let's build the audience. So we got it up to about 40 million fans all around the world. And suddenly it was like somebody magically just pulled the plug.
Yeah.
The whole world crashed in the fall of 2008, and all the funding dried up. There was just no way to put it together. So we tried again in 2009 and 2010, and I was laying out every single attempt we made. I was laying out 20,000 here, 20,000 there. And over time, it became a financial burden upon me. So I went back on coast to coast, probably 15 times talking about this expedition. I could never get the momentum back. So we finally got enough cash together from some projects and investments that I had made that we were going to do a dry run. So we bought the tickets to Moscow. We were going to fly to Moscow, then go to St. Petersburg, then go up to Murmansk, which is where the nuclear powered icebreakers are housed or are based, and shoot a pilot film to try to gain this momentum back for the project. And that's the year 2021 when they shut the whole damn world down. And I began to feel like a little I was being targeted or something. Of course, that's ridiculous. But the point is, we lost all our money. Again, all the flights, all the trains, all the hotels, everything, no refunds. That was another
Oh,
probably $22,000 down the hole. And so we have this project put together. We have a great business plan. We have a great plan to live stream from the ship on 4 channels so that anyone around the world could log in for like, I don't know, $12 and watch what we're doing for the 15 days of the expedition. We think it would be wildly popular. Everybody's interested in this project,
yeah.
and it's never been done before. This is a
Right, right.
very, very expensive, daring, and unique exploration above the Arctic Circle to see if there's an opening in the crust from our ocean to an inner ocean.
That's great. Do you have some slides to share on that particular project?
Yeah, sure. I mean, I can share some stuff on this. I do a live presentation that's 90 minutes long. And let's see here
I
if
think
you
that was
can
what I saw when I first saw you
see
present.
this.
Hmm.
All right. So this is a AI generated or a photoshopped version of what people think the hole in the North area in the Arctic Ocean looks like. It doesn't look like this. We have lots of satellite photos. We have lots of ground photos. It isn't like this. The Arctic Ocean in this region where we're going to try to explore is 4,400 meters deep. Okay. If you do the math, that's somewhere around 14,000 feet deep. It's very deep and very treacherous, filled with icebergs, filled with ice. It is not an easy project to go by or to venture to. It takes a nuclear powered icebreaker to make this trip. There's only one shipping company on Earth that makes that boat and operates that boat. It's an Arctica class icebreaker that's nuclear powered, and that's the Murmansk Shipping Company. That's who we contracted with, and it carries 125 passengers. So, what we planned to do was to, let's see if I can get to the slide here, was to follow up on a space mission that was done after the Cassini spacecraft made this discovery that there was an aurora over both poles at the same time. When the Cassini was on its way to Saturn, it turned around, shot a picture of Earth, and there were auroras over both poles at the same time. Well, that got my colleagues at JPL and subsequently their colleagues at NASA very excited, like, hey, we thought we understood where the auroras come from. Now we don't. So they put together what was called the Themis probe. And the Themis probe was a set of 5 satellites. This is a picture of them being put together. And they were put into a single cone and they were launched into orbit. And these satellites were then placed in different depths of orbit and they stacked up like a Jacob's ladder going out uh, toward the sun. Because the theory was that what happens is or the sun has an angry day, sends a lot of charged particles to the earth. They strike our upper atmosphere, sputter off a bunch of electrons, issue new photons, and that's what we see as the auroras. That's always been the theory. But here we had auroras over both poles at the same time. So we thought, well, how can you have a windward side and a leeward side and have auroras over both poles at the same time? So we were at least exploring the possibility that Earth and its magnetic field are involved in generating these auroras. We had no idea what we would find. And so what happened is when they turned the project on, during that period, there was a cosmic explosion, like a cosmic bullet. That's exactly what they called it in the report. Somewhere between satellites 4 and 5, this burst of energy out of nowhere, out of another dimension, occurred above the Earth. And when the shock wave from that explosion reached the upper atmosphere, the aurora appeared. So that was their report, that the auroras are caused by cosmic bullets. And that was it. And I thought, wow, you can't do that. You can't do one measurement and come to a conclusion like that. We need data. It needs to be reliable, repeatable. But they never did it again. So, and by the way, satellites 4 and 5 have been relocated. Now they're in orbit around the moon. They're involved in another project now. So that was the sort of graduating ceremony for the Themis project. And so that's where we are. And so now we realize that uh, the core of the Earth is not a molten ball like we all thought. We live on, this molten ball floating through space, and we live on, tectonic plates that float around like cornflakes on the surface. There's actually more structure to the Earth. We always thought that Earth was made up of a big molten ball, and it formed during this big accretion event. And what we realized is that that's not the case at all. Um, what we realized is that planets form multiple ways. One is that as they accumulate from these dust particles in the air, they spin faster and faster and faster. Sometimes they become unstable and they fly apart. Other times they become lopsided and they spit off a piece of themselves, like Venus spit off Mercury. Let's see if I can. I don't know if you can see that or not. Can you see the animated version of this occur?
No, it's not playing. It's just a solid
I
black
got you. Okay.
image.
All right. Let me just continue with that then, because I don't want to get too complex here. It will crash the whole thing. All right. Let's see here. Let's do that. Okay. Um, and sometimes they just don't fly apart. They just expand and cool, and expand and cool. And Earth is a good example of this kind of planet formation. Like an ice skater, when she lets her arms out, she slows down from her spin. And that's exactly what Earth is doing. You have this conservation of momentum. And so, hang on a second while I look at the auroras, floating around the Earth. It's quite spectacular.
Mhm.
These are real pictures from
Mhm.
satellite. Uh, and so several people have tried to explore it and have been turned away by the forces of the Earth. And some of them have used the seismic data we generate called seismograms. These are printouts from earthquakes that occur on the Earth. If we have a really bad earthquake, say in Chile or Japan along the Pacific Rim, these vibrations pass through the planet and they show up at other listening stations. So we didn't have computers, high powered computers in those days, but we nevertheless collected all the seismograms. So Dr. Y. Sessions at Washington University in St. Louis decided to employ, probably for cold pizza, his grad students. to go through all these seismograms. I want you to put all these seismograms into a computer and let's model the Earth from these seismograms. The earthquake happens here, the vibrations travel through the planet, they arrive at different times at different stations, and we can thus use it to kind of do a CAT scan of the Earth. And that's what they did. And what they discovered was another ocean the size of the Arctic Ocean underneath the Atlantic Ocean. And what they picked up were the damping waves, the waves crashing on a shore inside the planet. Well, holy crap, this lit the whole world on fire. We got to find this ocean. We got to somehow figure out what's going on here. Well, this seemed to dovetail into all the research we did in Arc of Millions of Years, that these people believed there was a world on the inside of our world. And if you go back to the flood themes that all these ancient civilizations have, it wasn't just rain that caused the flood. It was fountains of the earth that opened up. Water came up out of the earth and flooded the surface. So this seemed to dovetail into all those ancient stories, which were unique from Indonesia to the Sahara. It was the same story. So we came up with a hypothesis, our team. And this is basically the hypothesis. If there is an inner ocean, the way Dr. Y Sessions now has data to indicate, then it is chemically different than the ocean upon which we sail. That was a clear hypothesis. So they differ in salinity, they're exposed to different radiation, there are probably different life forms in the different bodies of water because they're isolated. And they're isolated, they develop differently. One is exposed to an inner source of energy, let's call it the core of the earth, and the other is exposed to the sun. Over millions of years, they're going to develop differently. And if that's the case, then we have a few questions that need to be answered. We answer those questions in the scientific method using experiments. And one of those experiments calls for gathering data at the one point where those two oceans might blend. And we think the easiest one is the Arctic Ocean because it's water instead of, tens of thousands of feet of ice like there is in the Antarctic. The Antarctic is heavily controlled with a 99 country treaty. You don't just take a boat down to the Antarctic and go walking around. You can't do that. But the Arctic is different. The Arctic is kind of like wilderness. You can pretty much go there anytime you want. So you just have to have the right equipment. In this case, it's a nuclear powered icebreaker. So our plan was to build some equipment, one of which I invented is called the Dart. Uh, we drop it off the side of the boat. It weighs about 300 pounds. So it takes a couple guys to toss this thing over the side. It uses its fins to aim straight down because it's falling through the water very slowly, but it's falling through the water. And when it hits the bottom, it inserts a pipe, which is about 1 meter long. And then it seals the end of the pipe. And then a few seconds later, once this dart senses there's no water flow over the side, which tells it, hey, I've hit something, I've stopped. A bag inflates and it floats the dart back to the surface. And depending on the shape of the bag and the volume of the bag, that takes about 3 hours to get to the surface. So somewhere around 4 hours later, we get the sample. We fish the dart out of the water, we deflate and repack the bag, we take the core out of the pipe, and we examine it. Now, the theory is, or not the theory, but the expectation is that somewhere close to that opening in the crust, 4,400 meters below the boat, there's going to be a difference in the sediment on the bottom of that ocean. It's going to have different skeletal remains, diatoms, microorganisms. It's going to have different salinity, different crystallinity. Something's going to be different about that. And What we're doing is taking 6 universities and their grad students with us on the boat, and we're going to do the analysis on the ship. And we think, or at least if the hypothesis is sound and proven true, then we're going to discover remnants of this inner sea because it's going to have inner forms of life that are different than the forms of life we see on the surface ocean. And if that proves the hypothesis true, then the theory that we live on a hollow Earth becomes much more credible. And that's what we want people to go with us and see in this 15 days at sea.
Brilliant.
Because these life forms we occasionally net in our fishing expeditions. We see frilled sharks, which you see in the upper left. We see all kinds of new species of rays. You see here a dorsal squid. We don't, those aren't alive in our oceans, and yet we do net them from time to time. We're not talking babies, we're talking mature animals. So these lived somewhere else and swam into our ocean and ended up getting caught. This is what we're trying to, um, for a lack of any other word, use the word prove. And I think if we can do this a couple of times, these expeditions cost about $4.25 million each to pull off, which would make it the most expensive expedition ever done on the face of the earth, and the first time it's ever been done. But if we do it and 40 million fans watch us, we'll have the money to do a second one. Then we have reliable and repeatable information, and that makes a theory solid.
Very good. Okay. You want to share another project, or should we go back to full screen and talk a bit about this one and what you need?
Let's just go back to full screen here. Let me see if I can stop sharing. How do I stop sharing? Oh, here we go. It's up at the top, isn't it? Well, if I hover over share, it should say stop sharing, but it's not saying that.
Okay, give me a second.
You can.
That was great, Brooks. Thanks so much. It's so exciting to see. And I know this is the thing that really drew me to you initially, despite the other great body of work that you have. Imagine someone out there wanting to go on a mission like this with you, and they've got a big enough wallet that they can do it. And there are always people that say, I've got money, I don't know what to do. Well, Brooks Agnew could do with your wallet right now. You'll be saving the world of information that's been put out that's wrong, and you'll be bringing a world of information that's right. Yes, inner earth, hollow. Yes, amazing things. Now, speak a little bit about your fishing expeditions so people can understand that you're not a crab fisherman, for example, but you do the
Well, okay. The business plan basically centers around this. We have 125 seats on the ship. There's a crew of about 125 on a ship like this. You can take a trip to the Arctic, take a trip to the Antarctic on these boats, but these are just like a cruise. We're not talking about a cruise here. We're going someplace no one has ever sailed before. There is no other ship on the planet that can make this route. We have a location that we think is the most likely location for this opening between the two oceans. It's about a 10,000 square mile possibility, which is basically 100 miles by 100 miles. Not that much to survey, but it's going to take 15 days to crisscross this area. And we'll get indications from the samples that we pull if we're getting close or not to the opening. Uh, for this 15 days, it's about, as I said, $4.25 million. That's to charter the ship, to get all the scientists from their respective universities, Washington, Stanford, Cambridge, these different places that have grad student teams that really would like to have access to this area, to get on, to get to the ship, get on the ship, do their experiments, get home, and ship their equipment home. That's $4.25 million. It's a lot of money, more
B,
than I can
B.
personally raise.
Say B with a B or M for million.
Million,
Yeah.
4.25 million.
Got
And so this makes it a very expensive expedition. And we could fail. We could just see nothing but whales and ice. But having people live stream, like this makes Deadliest Catch look like Gilligan's Island. So having people tune in to watch what's going on the ship, and we'll be downloading to both the European continent and the US continent. We already have the satellite space to do it. We think that there's a revenue model here that could make it self-sustaining. We would like to try. In order to do that, it's going to take the capital to actually make it happen. If you go to the fans and say, oh, send us 25 cents, they're not going to do it. Fans don't do that. We can barely get people to come out to live events, for a conference somewhere. Barely. They'd be happy to live stream it at home in their pajamas, but they don't want to come out to it. And as far as getting somebody like a rich billionaire to fund it and come on the boat with us, realize that these are among the roughest seas on the planet. The North Sea is nothing to mess with. We're talking 7 to 10 story seas. So this is not a pleasure cruise. This is an expedition. And it's rough. Breaking ice for 7 days just to get there is probably a time when you're not going to sleep because it's very loud breaking this ice. And it's not easy to do, but it is possible to do. And so we would like to give it a try. I would happily sell 20 seats on this boat for the seed money to do it. But I don't think the seed money is enough. Just because you raise the seed money doesn't mean you can raise the rest to get it done. And I don't want to risk anybody's money. Let's do the expedition because we can.
Yeah, yeah, you're right. And it's interesting too because, funders, and I've witnessed this, I've seen people do this. I saw a guy pull funding from a man who's doing beautiful work with children and education. And the man promised the funding, laid out, that was the cedar, the original cedar, and just pulled it, and it's just so cruel, in my opinion, and which I'm welcome to, of course, as we all are welcome to our own opinions. But yeah, again, I like to kind of go into a bit of detail that we're doing here so people can really think about, do I want to invest in this? Do I want to buy a place on that boat? I think it's a brilliant idea. Other people do too and will. And I think that you've been deliberately blocked, on this project, like I've told you that before, like and you've admitted like you are blocked, you're a targeted individual. Because if you do succeed in this great experiment, you're going to rewrite history. And there are
Well,
people.
that's what we're here for. We're here to make history, rewrite history, and correct things. I mean, for a long, long time, we thought we lived on this molten ball floating through space. I've got it in my geology textbooks right behind me. But that's a false model now. We now know from not only spectrographic data that we're getting from listening to deep places in the earth, and this has been reliable and repeatable from Japan to England to Carnegie Science in the Northeast universities of our own country. We've repeated those experiments by duplicating the conditions on the inside of the Earth, with what's called a diamond anvil. And we have now isolated the two spectrographic peaks that we're getting in our absorption experiments. We know that it's iron, and we know the iron is matrix with xenon. We can duplicate it. We can duplicate it chemically in the lab. If that's the case, and I think it's a very strong if, because we now have data to back it up, and it's been duplicated in 3 locations, then that means the structure of the Earth is different than what we were taught in school. We know we have a solid iron core. It is in crystalline form. It is somewhere around 6,000 degrees C, which means it's emitting light, a white light. I don't know if anybody's ever used a grow light to grow plants in their house, but that's the wavelength of light that's emitted by an iron crystal in the Earth. It means there's no ultraviolet radiation. There's only the light that's conducive for photosynthesis. And if you have light that's conducive to growing plants and you have an inner ocean crashing on inner shore, it's a reasonable assumption to say there's probably plant life there. And if there's plant life, it's a reasonable assumption to say it could support animal life. Well, holy cow, now you have an inner ecology inside the earth that's different than the ecology on the surface of the earth. Maybe it's just simple life like microbes or uh, microorganisms, but maybe there's also complex life like lizards or dinosaurs or fish or who knows? Who knows?
I know someone, I trust him with every cell in my body, and his name is JP. And he has been on expedition to Inner Earth, and he's the only person I've ever interviewed who, making a statement about going physically inside the Earth, and that is JP. And he has brought so much evidence, and he does it with the army, with the military, who know everything about it. Another reason why they don't want you to go and prove because they like to put a lid on everything, as we know. And he met the most beautiful beings. He met these ant beings, these giant, beautiful, just stunning looking. He drew them. They're just so beautiful and so elegant. And when he talks about them, it's mesmerizing. The other thing that was so fascinating, there's all this assumption, like inside the pyramids, are like, well, there's no soot, there's no evidence of fire. We're always assuming with our 3D brains and never respecting that the ancients knew more than we did, and we've been dumbing down and being dumbed down and dumber and dumber and dumber, till this point to stop us from having the wealth, the true history of our planet. So they have these fluorescent plants, and he saw them in inner Earth, that these beautiful fluorescent plants, they light up. There you go, John. There's your information. It's really quite simple if we just stop thinking with this thuddy donkey brain that has been force fed complete bollocks. Like you said, the textbooks you have, what good are they? Molten rock. It's a nonsense, isn't it? It really is. I think, again, it's so important to highlight these subjects. This is part of our right. This is part of what we are doing, what we will do, and will continue to do. And I stand very strong on this. This is disclosure. This is the true history of our planet. And you are very well suited and situated for such an expedition. And you've clearly done so much work into the researching. And the icebreaker, do you have an image of it that you could show us that you
Yeah,
designed?
sure I do. Yeah. Hang on a second. I got a picture of the Arctica class. Let's see here. The only ship of its kind on the planet. The Russian shipping company builds it, and they operate it. Let's see here. Here we go. I'll share this. Okay, you should be able to see the Arctica class now.
Yes.
So this is quite the ship, as you know. This is a drawing of it actually being built in the shipyard, and this is a class of ship. They're 450 feet long. They have 75,000 horsepower, and as I said, these are not easy seas to negotiate. Let's see if I can go back to that picture. So it has a heliport on the ship. It has the ability to carry 125 passengers in these 9 upper decks. It has a electric motors that are driven by a nuclear reactor, so it has a 3.5 year fuel supply. And these ships are capable of breaking ice for weeks on end, up to 6 meters thick. I've seen it back up and ram ice and actually break through ice walls to get into the area. It's a fantastic ship. It has rescued other ships that have been caught in the ice. Of course, my ancestor is Sir James Ross in Stranraer, Scotland. It's where my family is from. You can go there and see his bust in the hotel. Um, and Sir James Ross went in 1831, actually in 1830, to try to find the North Magnetic pole. And when he left out, uh, his ship got caught in the ice and it was smashed. And they rescued him at sea. See if I can get back to the Zoom meeting here. Uh, Stop sharing.
There you
Oh gosh, are we stuck here again?
go.
Um,
Hold on.
anyway, so my ancestor is Sir James Ross. He sailed out of Stranraer, Scotland, went in search for the North Magnetic Pole, and he was caught in the ice. His ship was smashed. They offloaded onto the ice, wintered on the ice, and was rescued the following spring. You'd think that was the end, but that is not what the Ross clan and the Agnew clan do. We try again. And so he tried again, and in 1831, he discovered the North Magnetic Pole. I show this slide sometimes in conferences, and people look at it and they look at me and they look at the slide, and I can see them mumbling out in the crowd. And I go, well, I'm back. So I'm kind of invited. I kind of have a legacy to go find this location.
Very
And you can
well
see by
done. You probably came back to continue the work, and there's a massive
the,
possibility of that. Absolutely.
yeah, because if the North Pole is not the North Pole, that is to say, our geographic North Pole is not our magnetic North Pole, then there has to be a source for this magnetism that surrounds our planet, protects us from the solar radiation, that's not linked to the crust. Or if it is linked to the crust, it's independent from the crust. And what we find in any let's call it a gyroscopic model, that there's a force called the Coriolis effect. And this is a force that pushes at a right angle against the rotation. So in other words, if you were standing in a schoolyard and you had a bucket of sand on a rope and you swung the bucket around your head, the sand would stay in the bucket because of this centripetal force. But if you cut that rope somewhere while you were spinning, the bucket would travel at a right angle to you away from that rotation. That's called the Coriolis effect.
Hmm.
Um, and that's what's happening as the core rotates at a very high speed and the crust rotates at an independent speed. There's a link between them that causes this magnetic field. That's how motors work. It's how generators work. They generate a magnetic field around them that's perpendicular to the rotation of that armature. That's what Earth is doing. It's a motor, it's a generator. That's what's making the magnetic field. The reason the North Pole wobbles is because the core of the Earth and the crust of the Earth are rotating independently. Even though they're on the same axis, there's a force that causes a wobble in that axis. That's what Sir James Ross theorized, and he proved it when he found the North Magnetic Pole. Now, that North Magnetic Pole isn't in this location anymore. It is moving toward the Siberian desert. More proof that we have an independent body on the inside of the planet that's responsible for this generation of that magnetic pole. We want to find the opening that leads us to this spot. And this is Sir James Ross' bust at the hotel, at the Ross Hotel Bar in Stranraer, Scotland, which is where my family is from. And there are others that have followed this earth. There's a Marshall Gardner who has filed a patent in the early 1900s on the hollow earth. He actually died of pneumonia contracted while he was looking for the opening in the Arctic, which, by the way, in the 60s and 70s was the only way to get there was by dog sled. And so Marshall Gardner actually died on the ice during one of these expeditions. Well, I don't want to go on a dog sled, and you can't fly over the North Pole because at 17,000 feet, you're not going to see anything but clouds. We want to go by sea. It's never been done before. We want to go by sea to see if we can find this opening. And that's our story. That's our expedition. That's what we want to do. And over the last, well, how long have I been doing this? Since 2007 is now 2024. 17 years, I've accumulated the largest body of solid scientific evidence contributing to this hypothesis that we live upon a hollow planet. We want to prove or disprove that hypothesis. Now, there are a lot of stories out there, a lot of remote viewers out there. I have respect for all of them. These are a different kind of fact. It's not reliable. It's not repeatable by an independent source. Yes, the stories are fascinating. A lot of them, including Admiral Byrd's diary, are perhaps credible, but not provable. I want scientific data. That's why I'm here on this planet, and I intend to do everything I can to make it come to pass.
Brilliant. Absolutely brilliant. Okay, while we're on the share screen, because we're having a bit of a technical difficulty to come out of it, we'll stay on it. Is there anything else that you need to be sharing here on this? And also, you mentioned Loch Ness, and there's so much information there on that we can go into a little bit. Yeah, let me know. And if not, then we'll just come out of share
Well,
screen.
you have to understand the crust of the Earth is not small. It's 900 miles thick. It's a lot of mass. The deepest hole we have ever drilled, which, by the way, is in Russia, is only 8 miles deep.
Mm.
That's as far as we've explored into the crust. The rest of it has to be done with instrumentation, has to be done with remote sensing, which is electronic or satellite based. And these are where the evidence is coming from to back our hypothesis that Earth might form as a hollow sphere. In fact, most planets probably form as hollow spheres. It makes sense. If you go back to, the early analysis of this, which was done by not only Sir Edmund Halley, but also by his contemporary colleague, um, who's responsible for the theory of gravity, right? Uh, this becomes very interesting because his thin shell physics, see if I can get to the previous slide here where you can see, uh, his theory of gravity is that once you're inside of a thin sphere, okay, gravity cancels out. That is to say, the gravitational field inside the sphere is zero because it cancels out. And his thick shell physics, this is complex enough mathematics, but his thick shell physics is just an extrapolation of his thin shell physics. So, what you realize is that planets can't form as solid balls because you get on the inside of the planet. If I get to my model here, I don't know where. Oh, I know what it is. I've got it embedded in that slide. If I activate that slide, you'll see it. Um, the model is, let's say that you and I are sitting in an elevator, or I'm sitting in an elevator because I'm not offended by my weight. I weigh 0.1 metric tons. Uh, if I'm standing on a scale inside the elevator and the elevator shaft goes to the center of the earth, now this is a thought experiment, and I hit the down button toward the center of the earth. It's going to take a while because we're, 3,800 miles to the center of the planet. As I descend, what do you think my weight does on the scale? It drops because we are accelerating toward the center of the earth at the rate of 32 feet per second per second. That's what creates our weight on the surface of the planet. We're actually falling, but this chair I'm sitting in, fortunately, is stopped my falling, and I experience the acceleration as gravity. But as I approach the center of the earth, my weight approaches zero. Why? Because there's no more any mass under my feet. The mass is all above my head. So I weigh zero. Well, if I weigh zero, then the mass in the center of the earth also weighs zero. That means it's attracted to the crust above its head. And that's why planets form as hollow spheres. Now, I could hear planetary core geologists, criticize me for this and yell because their uh, Ivy League sheepskin costs more than my sheepskin, which we call a diploma. But the math doesn't lie. Isaac Newton didn't lie. He created a math model, which is, as far as I'm concerned, provable. And we can't do it directly because obviously there is no elevator shaft going to the center of the planet. But theoretically, we can say that gravity at the exact center of the Earth is zero. And if it is zero, the only thing that's going to maintain a body inside our planet is going to be the strong molecular forces, which is one of the four forces of the universe. That iron has formed a solid crystal. That solid crystal is probably 12 to 1,500 miles in diameter. That's a lot of iron, somewhere around 13, 14 grams per cubic centimeter. That's a very dense, solid core that is rotating faster than the crust on the inside of the planet.
Amazing. Now, talking about the way that you have designed the drill that you have to bore to drill, is it more of a like a boring, turning, or is it more of a kind of a pneumatic? Uh,
Nope, it's just a dart. And it's made of steel. When you drop it in the water, its weight carries it to the bottom, just like a lawn dart would be, only slower. And it's heavy enough that it has enough momentum that when it hits the surface or the bottom of the sea, it's going to drive a coring pipe into that sediment, and then that's going to collect a sample. When the bag inflates under pressure, it's going to dislodge that dart and it's going to float back to the surface, carrying that 1 meter sample that we just cored out of the bottom of the sea. We're going to extract that core, not as a slurry, but as a solid piece, replace the pipe, and drop it again. And then over time, over the next few weeks or after we get back, those cores will be analyzed. Here's what we found. We found a high concentration of a diatom that does not exist in our ocean. We found bones. We found calcium. We found other elements that do not exist anywhere else on the sea bottom because they didn't come from our ocean. They came from an inner ocean.
yeah, that's just incredible. Let's go back to full screen now, unless there's anything left here that you want to really highlight.
Uh, Not that I can think of from my slide presentation.
Right.
I mean, I could demonstrate the diamond anvil. That's a few slides down here.
Yeah, let's do that
That's
because
a really good.
it's new work, it's new expedition, it's never been done in the way that you're proposing. So to give people as much intel as you can and imagery for them to get on board with you on this, and then come on this journey
All
with them
right.
in person.
So the spectrographic evidence of the core was first gathered in Japan, then duplicated by Cambridge, and then Carnegie Science put together an experiment in the lab. And what they built was what's called a diamond anvil. So this is a picture of what it looks like. It's an industrial diamond, and it's of course very hard, and it's put on a hydraulic ram. And then what they do is in between these diamonds, they put a crucible. It looks like this. Okay. Inside this, they duplicated this by putting pure iron into the crucible. And then they placed the crucible between the diamonds and smashed it to incredible pressures that they estimate are probably the pressures experienced on the inside of the planet. And then they shot a laser through the diamond to heat the crucible because what they wanted to do was match these absorption peaks that Japan picked up. We know that one of them is iron, but it only exists at a temperature of 6,000 degrees C, which happens to be the temperature of the surface of the sun. The other peak evaded them for a long time. They couldn't figure out what the other peak was. They just kept experimenting with different samples. And they finally matched it. And that match came with the gas xenon. Well, the interesting thing about xenon in particular is it makes up part of our atmosphere, right? It's a noble gas. Well, it also exists in the ocean, but the problem is 90% of it's missing. We can see it in the atmosphere, but in the ocean, it's missing. So we're trying to figure out why this law of partial pressures that we know is irrefutable in chemistry, especially liquid chemistry, why it was being violated by the absence of xenon. Well, we now know that massive amounts of xenon are matrixed with the iron in the core, and it forms this incredibly dense and high temperature solid core that we know as the Earth. And this has been duplicated, it's been repeated multiple times. This is good data. This is the kind of data that we're looking for. We're not talking about remote viewing. We're not talking about diaries. We're talking about solid evidence that matches the frequencies that we're receiving out of the inner Earth. And so that idea that we live on a hollow sphere uh, becomes bolstered. And here's my thought experiment, haha,
Mm.
where we take the elevator into the center of the Earth. So that's where that comes from. That's what we hope to gather another piece of data from the bottom of the ocean, 4,400 meters deep, using my darts. And I don't know how many we're going to be able to afford to build, but if we build a half dozen, it makes the project go a lot faster because it takes about 4 hours for the whole transit from the surface to the bottom and from the bottom back to the surface. So if we can rotate these darts, we could probably speed up the sampling process and we get it done in 15 days. Of course, there's another way to gather this data, and that's with a submersible. There is a submersible that has been built, but it's only good for 1,500 meters. That's as deep as it's ever gone because that's how long the cables are. To improve this, we've gotten with the company and asked them to put together a proposal to lengthen the cable and improve the submersible to go to 4,400 meters. That improvement costs $5 million. Would it be great to have? Yeah, I would love to see video from the bottom of that sea, but that's another $5 million onto the project.
Mm.
Maybe we do it for the second one.
You know, I knew a guy, I worked with him. His dad builds two-seater submarines, Hawks, Hawkes. I forget the name of the actual submarine company, but I was looking at selling them in England years and years ago. And they're absolutely fascinating. And we have the technology. We have it all. It's just hidden from us. You know, the free energy, the ability. I know this, you know this. This is part of my mission is to expose all of the hidden technology that holds us back.
Mhm.
You're getting into so many really, again, thought-provoking areas. Let's go
Well,
back.
that's what science is. It's
Yeah.
science is all about questions.
Yeah. Should we go back to full screen?
Yeah, we'll have to end and I'll have to come back in.
Okay, give me 1 second.
Okay.
Okay, so many thought-provoking images, memories, thoughts, ideas, knowledge, things I've witnessed. People are going to be so like, wow, 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 wow. In terms of the different land masses structures that we have, you mentioned earlier Japan, and we know or we're told that Japan exists on three tectonic plates. And I liked your analogy of them being like moving cornflakes. I'd never heard it quite put that way before. And why Japan in particular, that's part of the earth, is so vulnerable, let's say. But my God, some great technologies come out of there, like the earthquake. They've got their buildings on wooden joints that move, and like, why isn't the rest of the world set up that way? It should be. Galapagos Islands as a way of taking specimens to this day. Darwin, for example, is very much lauded for his work in the Galapagos Islands, of which there are many, and that it is an absolute treasure trove in the water around and on land in the Galapagos Islands, they're still finding brand new species of animal today. The assumptions made that the tortoise that live there can only go this high, their little bodies can't absorb or, exchange the, carbon, whatever, that's needed to breathe and live. And they realized that was nonsense because they thought they knew and yet they didn't. And that's, I think, often the failing of the human. We think we know, but we didn't. We were going down a wrong path, or perhaps we were led down that path. Also, right? I also
Yeah,
wrote.
well, I've made a career out of it. I'm a master engineer, which means I have skills in electrical, chemical, and mechanical engineering. And I integrate those forms of engineering. And that's why the Fortune 100 hires me. They hire me to come. And you'd think the Fortune 100, well, they know everything, they know how to make stuff. But you'd be surprised how many things they have designed, they haven't figured out how to manufacture yet. So that's why they call me in to solve those problems and get those products into manufacture. I've been paid very well to do it. I'm one of the few engineers in the world that do this. Most people are specialists and they get lost, just like the Galapagos. Here's something isolated from the rest of the world. It adapted to its environment and developed differently than tortoises in, say, the American desert or in other areas around the earth. Science does that all the time. But what happens in our industry of science, I'm sorry to say, is we develop a kind of religion to it. We have high priests in science. And I can't tell you how many stories I have read of physicists who have made great breakthroughs or mathematicians. They come to a conference, they make their presentation, and they are excoriated so badly. There's a record of them going home and committing suicide because they're rejected by their community so badly. I read a book on biographies of mathematicians. I know you'd think that's really nerdy. Well, I suppose it is, but it was a fascinating book because all of these mathematicians, from Sandra Cassar to Riemann to these great mathematicians that make great breakthroughs that changed our world, really, they claim that they received their mathematics in dreams and in visions. And they don't receive, like a development of the mathematics. They receive the finished mathematics. Well, the problem is there isn't any developmental math to get there. So once they introduce their new math, it takes years for the mathematicians of the world to develop the derivations to get there. And I'm sorry to say that's the way math has evolved. Well, the same thing with science. When I wanted to learn more about the hollow earth because the ancients had all this information that we had collected and published in our book, The Ark of Millions of Years, in the 4 volume set, there wasn't anybody doing it. Well, I'm kind of X factor that way. And in that, well, if nobody's doing it, then why don't I do it? Why not? And that's how the whole North Pole Inner Earth expedition came of age. Now, yeah, there are lots of people out there claiming to give lectures on the hollow earth. I've probably met 50 of them at various conferences. And I just nod my head. I can't criticize them because, they're contributing to the science, but it isn't science. Science is a method of collecting data to prove or disprove hypotheses.
That's a very good point again. You make lots of good points, Dr. Brooks Agnew, you do, sir. And one of them being that, you're witnessing different people with their their versions of Hollow Earth, and I would say 99.9% have potentially actually physically not been there, which is what you need. You want the proof, the concrete physical proof. This is how I work. You need that. And what a lot of people today, like in the whole galactic, it's so trendy to be in touch with aliens, and that's a complete reality that I'm very much forefront of. And my contactee experience is physical, which is why I'm so damn passionate about the subject, but also very clear on landing galactics with the military, with science, with governments, with all corrupted systems, because they've all done one thing, and that's block our history and the truth of our planet. All of
Yeah,
them.
they have.
all of
Yeah.
them. So what you get in the galactic, let's say, like I did a brilliant broadcast with Alex Collier and Marcella Valesco, both Andromedans, who are absolutely kicking ass and taking names on. No, that does not happen in Andromeda. They are not doing this. Their ships are not made like this. They're like, no, enough. And then they're putting the information back again out into the field as it should be, as I mentioned earlier to you. And this is what we need, and you again saying that I admire that, that you have witnessed 50 hollow earth experts, and yet not one of them can potentially prove it's theology, it's thought, it's taken from here, taken from there. And I watch people putting information out in whatever regard, and maybe they're sitting on their phone. Why are you sitting on your phone? You got to talk from experience. You got to give that passion. You got to show your evidence. You got to make a case for it. You have a finished symbol, mathematical equation, algebraic phenomenon, and you've got to make that journey from that point to that point, or shut up. We're all bored. And I admire you for being one who has struggled. And I know you've struggled. And it's been a hard, bloody slog for you. But at least you're putting one foot in front of another and you're making your case, physically, mentally, and emotionally. And now we just need to land that financially. You feel me, Brooks? Dr. Brooks?
Yeah. Unfortunately, these things do take money, and it's we're not taught. We went to the National Science Foundation and we asked for a small grant to do an exploratory study. It wasn't much of a grant. I think it was $40,000 or something like that. It came with so many strings. They wanted all of our data, they wanted access to our finished product. And we said, we just can't do that because we know what you're going to do with it. You're going to sequester it. And that's not what we're about. This is a public venture. We want everyone to see what we see when we see it. And they wouldn't go along with it. So we said, okay, well, we'll do it another way. We went to Richard Branson. He's one of the richest men in the world, noted for doing these kinds of things. We started to make our presentation and we got to a certain point, and their staffer said, now, once you sign this paper, it's our project and you may or may not be involved with it. We take it from there. And I said, honestly, I'm not being selfish. I'm not all that. I don't care if my name is associated with the finished product or not, but the public wants to know. And if you take this and you sequester it and you make it Richard Branson's project, that just doesn't stick with the spirit of what I've been entrusted with. So we're going to pass. And we passed. We walked out.
you know, bless you. And I know that's so hard, but you didn't sell your soul to the dark or the devil. And what we're doing here, what I'm deliberately doing is not leading you into, but showing the people watching this that even you, as a PhD, a doctor of science, deeply devoted to proving your points, your case, your science itself, that you run into the same walls that everybody else does in each of the individual systems that exist on our planet. And it's tragic. I met a man years ago. I used to, well, I had a clinic in Harley Street. In Harley Street, London, if you get a clinic there as a therapist, which I did, #1 Harley Street, Suite 9, it's a big deal, or it used to be a big deal. I don't know what it's like now because I no longer am practicing in clinic in London. A doctor came to me, we'll call him Dr. Richard, and for chronic stress and anxiety, and that's one of my specialties. And he was so at the end of his rope and like really going down a dark road. And because his funding had been taken for a project, a breakthrough, and the breakthrough is this: men that need a biopsy taken of their prostate gland. And as you know, the prostate gland is, in the anus. The best way to get to it is up the anus. And they use a machine, and my ex-husband had this done. And it's like a stapler, a puncher, and it punches, yes. And my husband was terrified to have it done because he'd heard horror stories, and he had it done, and it was agony. And he was not himself for a couple of days. It was a lot of trauma. And I think it's desperately, desperately evil that these barbaric torture tools are still using women with the speculum and taking their samples and doing their smear tests. It's diabolical. Anyway, here's my point. He'd proven that by taking a sample of urine from the man and harvesting the cells and analyze them in a particular way he'd developed, that they could measure the PSI, the state where the prostate, levels are.
Yeah.
And funding was blocked. And he just,
Oh,
yes, as 1,000 million other people with their funding blocked, or they say to you, sure, we'll let you do it, but we're going to take it off you. You'll be nowhere and nothing. They can catch and kill it. They can silence that work, and they do, or they'll block your funding. So it's terrible. Anyway, Dr. Richard did recover. I did quite a few sessions with him. He's a darling, lovely man. And sadly, he had to acquiesce and say, well, I know how to prevent men going through that, but there are people that don't want the information out there. And that's been the story of the planet of our world. And people,
yeah.
there's so
Well,
much.
we've experienced this at our conferences too. Agents that are sent into conferences to basically mislead people or to create, let's call it a schism in the science. When we first started doing conferences way back in 2005, I was invited to my first conference and I got on Coast to Coast AM, and I've been on, I don't know, 20, 25 times on Coast to Coast. The audience has been fractured by these agents that are sent in to conferences like Contact in the Desert, like ESETI. They're sent in to split out and confuse. And I think one of the most diabolical plots that I've ever seen came straight from the bowels of hell. I mean, right out of, I mean, I don't even know how to describe how crazy this is, but it's almost like a religion that has been introduced into our science. And it's fractured the entire audience. I've seen it right here in Charlotte. They had a conference last year. I just cruised by it, walked through it to see, and it's the same wild-eyed religious fanatics that come in here and fracture this science. And the theory that has done this, that has really tectonically blasted our entire community, is this notion of a flat earth.
Oh, yeah.
It's insanity. I just came back 3 weeks ago from LIGO, the Laser Interferometer Gravitational Wave Observatory. I have now been to three of them on the planet, probably one of the only scientists that has been, other than the ones from Caltech. And this is not only measuring, gravitational waves coming through our neck of the galaxy. They're very expensive, about $100 million per facility. And we have directly measured now black holes. They won the Nobel Prize in 2017 for doing it. But one of the things that it proves irrefutably, because it's a 4 kilometer long laser that they're shooting to a sapphire mirror, which bounces off the mirror and comes back. So it's really 8 kilometers long. But if you stand at the transmitter of the laser is about 8 inches off the ground. If you walk to the end of the 4 kilometer tunnel, and I have photographs to prove it, the laser is about 24 inches off the ground. Why? Because in 4 kilometers, the earth curves
Mm.
and the laser's straight. Proof that the earth is not flat, it is curved, it is round. These are the only lasers on the planet. The largest Michelson-Morley interferometers ever built proves that the earth is not flat with instruments.
Yeah, you can tell people, you can show them, you can drag them, you can push their face right up against, let's say, a UFO, which I did 2 weeks ago. And if something inside of them doesn't want you to be popular, doesn't want the information to get out because they're not part of it, they didn't make it happen, whatever the inner agenda is. I witnessed even this week when we said that there were going to be UFO craft flying over our conference in Colorado, not Denver, Westminster, Colorado. So Elena Danan proved she's in physical contact that the Earth military know her. And I keep talking about it, and I am going to keep talking about it because we made history. It should be all over the news. It's not. And now the agents are coming in and they're trying to crush it. They're trying to suffocate it. Now, I'll tell you one fake thing. MUFON, Mutual UFO Network. There are people there proven this week to sabotage and disinform and fracture, like you were saying. And this bloke in France is really good friends with a couple of the speakers who spoke on the stage, put out a hit piece saying it was birds. Now, any ding dong of any age or mentality level could look up and see there were birds or bats, as Alex Collier said they could be, because he lives there. You could tell which were the UFOs. We were shining a laser light, hitting the metallic structure, whatever composite materials they build those craft with, hitting, and they were flashing green lights. Now, I'm not sure if there are any birds made of metal with flashing green lights. Answers on the postcode, please, to Ding Dong Land. And so we have this deliberate sabotage of a man in France who works for MUFON, who professes to be best friends of one of the speakers. Why? And now, of course, I jumped in with my Dr. Martin boots and my baseball bat. I did, and I will, because I will defend truth. And then it's funny, people go, that's not very spiritual, Danny. I'm like, we've also got to reword and finite and understand what spiritual means. It's passion. It's being a warrior. It's getting proof. It's standing up for people, like me, like you, who are bringing truth, who are bringing disclosure. There's a hollow earth. You know it with every fiber in your body. You figured out how to put together the expedition. And all you need now is the funds to push it. And I admire you for that. Now, I have a question on the boat, the ice-breaking boat, so people again can fully, and I don't know the answer to this. I mean, I've seen things in the Arctic, get stuck, ice-breaking, and they're using kind of really strong, powerful motors, to push through. So the boat that you're proposing to go on, when it comes and meets the ice and it's going to break through, how is it doing that? What is the mechanisms around it?
Oh, it has an ice-breaking hull. Now, there are ice-rated hulls, which the Norwegians operate, but they won't go above the 80th parallel. They're just ice-rated. An actual icebreaker has a specially designed hull that's designed to actually push the boat up onto the ice, and the weight of the boat cracks the ice and moves it out of the way. Of course, the 75,000 horsepower motors don't hurt. These boats, the Arctica class, can actually rescue other boats that are caught in the ice. That's how powerful this is. In fact, the Mermuk's shipping company has actually rescued whales that have become trapped in, say, an open body of water, but surrounded by ice. Because in the Arctic, once the weather turns, which is usually sometime in early November, once the weather turns, the ice can actually form at the rate of 8 miles a day.
Oh.
8 miles a day. That's how fast the ice forms. And in 2008, we had a very warm summer up there, a warm winter, I mean. And what happened was there was a prevailing wind that occurred, and it stressed the ice. And those people that are aware of Arctic and Antarctic terminology, the ice calved, like a cow having a calf. It calved, so it cracked a huge piece of ice off, and the wind shear pulled it away, and it opened the Northwest Passage for the first time in, I don't know, maybe 5,000 years. It's never been sailed before, so we don't know. But it opened it for the first time. And it was that summer, the 2009 summer, that we saw these crazy life forms that showed up in our sea samples that were taken by places like Scripps University. Every 5 years, they go sample the rays of the ocean. Rays are like tree frogs. Tree frogs in the Amazon are very sensitive to pollution. So if there's pollution that ends up in the rainforest, the tree frogs mutate like crazy. They form like 6 legs and different species pop out, and they're sampled all the time. Well, rays do the same thing in the ocean. So every year they go down and sample, they find 25, 35, mutations that have occurred in the rays. But when they went in 2009, they found 1,500 new species of rays, adult animals that were different than anything we've ever seen before. And that we believe that these actually grew up in another body of water. And they entered our body of water through that Northwest Passage, hit the Gulf Stream, and were drawn into the tropics where they were netted. That's just a hypothesis. It has never happened before or since, but the ice in the Arctic has returned. So we don't know. The red ice in the Arctic means ice that lasts through the summer, and then it snowed on again in the winter. That's called red ice. So the red ice is back in the Arctic. It freezes, from shore to shore. The idea that Earth is warming and that sea level is changing. I can tell you, Danny, I just got back from Greece and Italy. Just got back, and sea level is right where it was 5,000 years ago. It hasn't changed.
Yeah. Yeah, it's so tragic. I think they're calling it not global warming now. Don't they call it climate change now? They're pushing
Yes, climate change,
that.
right? It's changing. And the
Yeah.
big thing is, of course, humans are responsible for that change. So, damn it, give us your money.
Yes.
How does
It's
that fit?
exactly. Listen, before we close here, and this has been absolutely wonderful, as I knew it would be, and I've given us plenty of time to really make sure that we really highlight you and your body and breadth of work and knowledge. Um, can you explain to people that don't know the difference between Arctic and Antarctic and
Oh,
where
sure, sure.
locations are, please? Because it's a lot of confusion here.
Yeah, well, only flat earthers are confused. The Arctic is on the North Pole. All right. It forms between a group of islands, between San Josef Islands and Canada. And this is where the ocean is very deep, but it faces the north. Okay. It faces the North Star. The Antarctic is on the South Pole. It is an enormous continent and it is covered in ice, and there's ice in the sea around that. So, yes, it is losing ice, but it's also gaining ice. So, it's kind of a balance between what side gets ice and what side doesn't get ice. But it is pretty much the same size as it's always been. It's just moving around. Ice is actually a liquid, it just moves very slowly. I went to Chamonix at the middle of September. Chamonix is in France. It is they had the Olympics there, so it's a big ski kind of place, but it's a small town. And if you go to Chamonix, you can take a train and then a gondola, and you can get up to the glacier that's up there in the mountains. Now, it is receded about 1,500 feet from where the resort was actually originally built. So there's a gondola you can get in, which will take you down to this glacier. Now, this is pretty amazing what they've done is they have actually bored using hot water tunnels back into this glacier, and you can go inside the glacier and look at the blue ice all around you. Oh, the photographs and videos I took on there are just stunning. But the weird thing is when you get inside this glacier, which is, I don't know, maybe 1 million years old, I don't know, huge uh, a body of ice, it's still flowing just very slowly. It is under such stress. And water is a very unique molecule in the sense that its angle, the 110 degrees between the oxygen and the two hydrogens on it, is very unique in the universe. When it freezes, it expands instead of getting smaller, like most things when they get cold. No pun intended there. It expands when it gets cold. Well, that expansion causes a tremendous amount of stress, and that stress in water turns into a kind of plasma magnetic field. When you're inside the glacier, surrounded by ice, with the exception of this tunnel that they bored through it, you actually become disoriented, like vertigo. Your body responds to this magnetic field. And I comment on it in the film that I shot down there. But the ice is as blue as a robin's egg. It's amazing, amazing what they've done in Chamonix. So
Mm.
that's how I know a little bit about ice because I was actually in the refrigerator for a
Oh,
few hours.
that's so beautiful. In Chamonix in France, there was a an avalanche there recently, wasn't there? And the whole, yeah, it was Chamonix, wasn't it? Yeah.
Yeah, it didn't damage any of the town itself, but you could see where the trees were kind of broken off and stripped away. Avalanches are a big problem in the Alps, big problem.
Yeah,
And
definitely.
by the way, I decided not to fly from Geneva to Rome. We took the train through the Alps.
Oh,
Stunning.
oh my God.
If you get a chance, it's difficult to book and kind of a foot race to get from one platform to another when it stops at various places. But if you ever get a chance, you should take the train through the Alps. It will take your breath away.
So beautiful. I remember when I lived in Canada, I used to be a nursery nurse and I lived in Calgary, Alberta. So Banff is like an hour and a
Oh
half
yeah.
road where there also was Olympics. And there is a glacier there that overlooks Lake Louise in the Chateau Lake Louise. And I took a boat with a friend out on the lake and it was so ethereal. I was like 21. It was ethereal. It was moving. It was otherworldly. It was other dimensional. It was just so stunning. This planet is so beautiful. There are so many things to still witness and breathe. And like getting the train to Machu Picchu, taking the train, I did that. That was again another out of body experience. It's just so beautiful. I feel so lucky that, I've done these things, and I'm sure you do too. And those of you that have had wonderful experiences, and there'll be plenty more to come. Listen, Mister. Dr. Brooks Agnew, I have thoroughly enjoyed having you on my
Me
channel.
too.
I knew I would. And I know it's been a few years since we got together and sat and had a beer as such, or water, which is more the case these days.
I've been drinking coffee all morning, so I'm in good shape.
I love it. I love it. So let us give your final thoughts. What would you like to leave with the audience that will see this?
Well, I think everything we do eventually affects the universe, so we should do it on purpose. We should not be driven around by every wind of doctrine. Dream large and write those dreams down, and you'll find over time that you follow them. If you don't write them down, they just blow away in the wind. So dream large and discover and build great things. I promise you, mortal life is very rewarding. Even the challenges, even the blockages, they can be overcome. Why? Because we can. Because we are great beings and we are older than worlds.
Mm. That was a massive sentence right there. We are older than worlds. Oh my goodness. Yes, we are indeed. Well, Dr. Brooks Agnew, I will make sure that all of your contact details and book links are underneath this broadcast, everyone. Just go underneath, please. Just go straight underneath. Look at the screen underneath. Some people still can't find people's details, so I do try and help very much with that. And then hopefully Brooks will be in the live chat with us too when this premieres, if he's available. But I'll also drop links in there as as it's actually going out. So I think that it would be nice if we could invite the audience to maybe write some questions in the comment section. So we could potentially do a Q&A in a couple of weeks based
I
on
love questions. Love questions. Bring
that.
them on.
Yeah, let's do that. I think that would be really nice for my audience. I'd say my audience, the beautiful beloveds that come and watch the content on my channel, my broadcast, my real life, real time, beautiful people that come and play with me and share their life with me. And for yeah, people to ask you questions, and then we'll do a Q&A next time. And because I know you will have just, triggered the memories and the mind and the questions from many people. And anybody that wishes to donate to Dr. Brooks Agnew, please do not say you're waiting for the RV. Okay, we ain't got time for that. I don't mean to
On,
be
on
rude.
my website, there's a link to the North Pole Inner Earth Expedition. It's right there in the menu. If you go to brooksagnew.com, right up at the top, click the About link, and you'll see the North Pole Inner Earth Expedition. You can go there, you can see our business plan, you can learn all about the project, and you can contribute.
There, brilliant. That's what we want. Okay, brilliant. Well, thank you so much, Dr. Brooks Agnew. See you soon, sir.
My pleasure.
And to you beautiful guys out there, thank you for hanging in there with us. Thank you for paying attention to Dr. Brooks's great work. He's written so many books. We didn't have even a moment to get into those. Maybe next time we can actually bring some of
I
those
was going
up.
to add just one more thing. Anybody that saw the movie, King Kong and Godzilla, or the Godzilla movie where Godzilla disappears off the screen, I'm in the movie, but I ended up on the editing room floor. Okay, here's what they say. Dr. Brooks was right. The earth is hollow. It's in the movie. Check it out.
Oh my goodness. Oh my goodness. Bless your heart. Well, until next time, everyone, I send love from my heart to yours, and I will see you soon.
Thank you.